What is meant by hydroboration-oxidation? Illustrated with an example. Now, very interesting question. Hydroboration means addition of BH3 to an alkene. Hydroboration, you add hydrogen, and boration, you also add boron. Addition of a hydrogen atom and a boron group directly to an alkene or an alkyne, that is called hydroboration. And oxidation, that is another step of a different reaction in which if you take hydroborated alkene or alkyne and if they are oxidized to an alcohol using peroxides, that is the oxidation reaction. Let's take a better look at this. First, I'll just demonstrate what is hydroboration. Say we have propene, right? And this is subjected to diborane in, say, diethyl ether. Now, are you aware that diborane in ether actually remains like this, BHH? What is this? Ether has donated a lone pair to boron, and instead of remaining B2H6, it has actually split into two parts, BH3 and BH3, and each BH3 goes with one ether molecule. So I essentially have a BH3 group sitting like this in this solution. And as this BH3 group comes close, oh my God, this is very exciting. Yes, it is. As this BH3 group comes close, what happens is something miraculous. You find that this gets attached here and this gets attached here. What? Yes, you find that H, and it actually splits up as H and BH2. And it adds, and yes, this is an anti-Markovnikov addition. Hydrogen goes to that carbon which has lesser number of hydrogens. Why? Because boron tends to get attached to that carbon which can conveniently support negative charge, whatever the reasons may be. Let's not get into that. But the thing is, what you must remember is H and BH2 get attached, yes, and this is anti-Markovnikov addition. What does that mean? It means that boron gets attached to the carbon which has greater number of hydrogens, and H atom gets attached to that carbon which has lesser number of hydrogens. Wow. That's it. This is hydroboration. And this molecule is called alkyl borane. Fancy. And please see, this is of course propyl group. So I have BHH and a propyl group. This can again add one more alkene. And you know what do you get? Dialkyl borane. And the fun part is, please keep them separate. They're not continuous, of course. This is different. This dialkyl borane can react with one more alkene to give you trialkyl borane. All these reactions are hydroboration reactions. Hydroboration step 1, hydroboration step 2, hydroboration step 3. All are anti-Markovnikov additions, my dear. So this is the concept of hydroboration. First part. What is the second part? Oxidation. Let's talk about oxidation. When these alkyl boranes are treated with NaOH and H2O2, you have R3B, and you use NaOH and H2O2. You know what happens? HOOH forms HOO minus. This is the reaction. You get peroxide anion. And this HOO minus, OOH minus, oh my God, it goes and attacks it. So you get B, R, and OOH. Something like this. Wonderful. And what happens? Then what happens is, I hope you can see, oxygen hates oxygen anymore. I mean, this is one element, they don't love each other anyways. If one OH minus tries to break away, if one OH minus tries to break away with electrons, please note that is disastrous. Why? Why is that disastrous? Because that would contain a plus charge and an empty orbital on the adjacent oxygen atom. So the moment this happens, one alkyl group jumps. And what do you get? You get B, R, R, O. And this R has jumped here. This R group has jumped here like this. And one OH minus has just broken away out of hatred, general stupidity. Fanciful. Now, alkyl group gets attached to oxygen. This is the fun part you must notice. And what else? Slowly you would find, if you repeat this thrice, you get B, OR, 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 trialkoxyborane. And as, because NaOH is already there, OH minus can come in and RO minus can go out. So you get B, OH whole thrice plus 3 times ROH. Actually, you'll get RO minus, and RO minus with H2O will give you ROH like this. Right? So you get alcohols. The fun part is, you remember your alkyl, your propene, this was propene, right? One OH had got attached here. Sorry, one H had got attached here. Yeah. Now, wherever there was boron, that has now changed to OH. So these H and OH get attached to the alkene as anti-Markovnikov addition. So what is meant by hydroboration-oxidation reaction? I repeat, meaning of hydroboration is reaction of an alkene or alkyne with B2H6 in dry ether. The product of the reaction is trialkyl borane. That is called hydroboration. Addition of H and BH2 groups to alkene or alkyne is hydroboration. What is oxidation? When alkyl borane or dialkyl borane or trialkyl borane is treated with NaOH and H2O2. NaOH and H2O2, an oxidation reaction happens giving you an alcohol. And this alcohol is as if H and OH have been added to original alkene or alkyne in anti-Markovnikov fashion. And is this an example? This is a very standard example.